So another question, show that any real constant a and b where b is greater than 0, and we are given with this equation n plus a to the power b equals to theta of n to the power b. Now again we have to prove the theta notation here, and we are given with this that the two constants a and b, here we are using two constants a and b, where the condition is given only for the constant b which is greater than 0. No condition is given for the constant a, right? Now to solve this question, let us use some tricks and solve it. Okay, so if we compare it with the theta notation, that means here we have to prove that this is the fn function. This is the fn function, that is n plus a to the power b. This is the fn function. So one time we have to prove this function as smaller function, and one time we have to prove this function as greater function with this gn function. Gn function is n to the power b, gn function with some constants c1 and c2. Okay, and this one is greater than or equals to 0. So this equation we have to prove for all n greater than or equals to on n naught. Okay, for all n greater than equals to n naught. Now let's see how we'll prove it. Now let us take the first condition, fn is n plus a. N plus a. Now this n plus a, we can write it also as n plus mod of a, right? N plus mod of a. Now in these two terms, which is greater? If we put n equals to 5, then it will be n plus 5, it will be also n plus 5. But if we put n equals to if we put a equals to minus 5, then it will be a minus 5, right? But it will be n plus 5 only, right? It will be n minus 5 and it will be n plus 5 only. So that means for every value of a, this n plus mod a is always greater, right? Now to prove the upper bound, what we'll do, we put constants, we replace constants with the next higher order terms, right? So if we put mod of a is equals to n, right? If we put mod of a equals to n, greater than or equals to n, then it will become twice of n, right? Now we can also do write like that this n plus a. Now if we write this as n minus mod of a, n minus mod of a, then for this relation n plus a is always greater, right? N plus a is always greater. Now to prove this term as a smaller term, what we will replace mod of a. So if we'll put mod of a is less than or equals to n by 2, okay, n by 2, then for this term, this n minus mod of a is always greater than n by 2, right? N minus n by 2 will be n by 2 only. Okay, so we had these two ranges. We have two range. One time we have mod of a is less than or equals to n. This is the range of this. And one time we are placing mod of a is less than or equals to n by 2. That means this is the range. So the common range is n by 2 only. Okay. So we can, if we combine these two equations, we can write it as, we have n plus a, okay, n plus a, and it is sandwiched between, this n plus a is sandwiched between n by 2. For this it is always greater, and for this it is always smaller, and this n by 2 is greater than 0, right? Where the common range is, this is satisfying when mod of a is less than or equals to n by 2. Or from here we can write it as that n is always greater than or equals to twice of a. Now in the question it is given that b is a constant which is always greater than 0. Now for proving this given equation, here the whole term to the power b is given. The whole term to the power b is given. So after deriving this equation, if we put the power b, then it will also not affect. Okay, since b is greater than 0, so this inequality, okay, the inequality still holds when all parts are raised to power b, So we can also write this inequality as 0 is less than or equals to n by 2 to the power b, this term also to the power b, it is a, n plus a to the power b, and again this term is also to the power b. Also we can write it as taking the constants out, it is 1 by 2 to the power b into n to the power b, n plus a to the power b, and taking the constant out, it is n to the power b, right? So if we compare it with this standard equation, with this one, this is standard equation, so here we can get this standard equation and the derived equation. Okay, so here we'll get the constant c1 as 1 upon 2 to the power b, the constant c2 as 2 to the power b, and the value of n naught is this one, 2 of mod a, right? So after deriving this equation, we had proved that n plus a to the power b is theta of n to the power b. Okay.